Alright, should be another DraftPhysics.com video presentation. Try to just deal with one subject, Pyrrho's response to the history question. And in it is the 1.4 thing, the idea that it is kinetic energy that bends springs. And I'll just point out how even if they find this to be true, it still leaves you with a paradox in terms of a free energy paradox. So it doesn't fix the problem. The problem is you have two things that can't be compatible, momentum and kinetic energy. They both can't be real things. It's not possible. Because if you break one, then you're creating free momentum. If you break the other, then you're creating free energy. So if you keep momentum, kinetic energy creates free energy. If you keep kinetic energy, momentum makes free momentum. They can't coexist as answers to the question. It's a paradox, it's nonsense, it's idiotic. So, demonstrating how idiotic it is its history. Okay, and they just keep denying the history. So the question's asked. So I'm asking you to comment on the history. Was smuggling God back into Newton's godless ideas a real the idea is a real objective back then? So let's understand, Newton was a religious nut, but clearly he didn't put any religious crap in his physics, okay? He didn't make the physics match his religion. Leibniz, on the other hand, was again not so restrained. He thought the physics should match God's design, and he objected to Newton's physics being accepted because it was too austere. It didn't have a role for God to play. That's the basic start of this whole thing. This whole let's reject Newton's momentum physics and create some new kinetic energy physics. And this is exactly its origin. This is where it came from. Those are facts. Okay? No one's refuted them. The history is the history. It's just a fact. So Pyrrho's response is this doesn't matter. So it doesn't matter that the original formula for kinetic energy, living force, was mv squared. Okay, so in the 1800s, 1805, let's say, they made it 1/2 mv squared. So that's when they first started using the half mv squared. So this is a 100. Because of this half, these numbers end up being 100% different. I mean, if this says 50, if this says 100, this says 50, obviously. Gigantic discrepancy. Just humongous. Okay, so let's understand that it started here. Then they, so Leibniz didn't have any experiments. He just used a bunch of semantics and rhetoric to say, well, it's 4 times higher in gravity and it's blah, 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 that kind of argument, but nothing like physical. Okay, so Leibniz died, no one, okay, because no one accepted his mv squared, lost the first round. Okay, the first round of argument about whether it should be mv to define energy or mv squared. First round, Newton wins. Newton's a hero. Newton's God. Blah, blah, blah. All right, after Newton's dead, or nearly dead, this French woman digs up this crap, okay, this Leibniz crap, and revitalizes it. And then she uses the experiments from some Dutch guy, I think, clay experiments, okay. And so what the clay does is it allows fast things to go deeper into the clay. I'm just arguing that that's the fact of what clay does. Clay has a bias. Slow things get stuck in the clay. Fast things penetrate the clay deeper. So when you tested, different things, doubling the velocity, doubling the velocity would get you 4 times the penetration in the clay. Okay, so yes, it verified mv squared, okay, because doubling the velocity got you 4 times the penetration in the clay. Now, the trick is that proves mv squared. It doesn't prove 1/2 mv squared, right? So the modern formula says the clay experiment has to be wrong. The clay experiment produces a result that's incorrect by the modern formula standards. So clearly the evidence that won the day back in 1725 or 7 was crap, obviously. Because modern standards say it was wrong. It was incorrect. It was a wrong interpretation. It was an error. Error. Okay? Okay. So this is the joke. They clearly don't have any now. So they don't have the clay experiments anymore. Madame de Châtelet's bullshit experiments have all been discredited as incorrect, as 100% incorrect, as getting 100% too much of an answer. 100 joules versus 200 joules. I mean, a very big error. So all of that science, the 16th and 17th century, 1600s and 1700s, all of that science was killed in 1805 when they put the 1/2 on it. Right then they said all that science was junk. And now, but they don't have anything to defend this, okay, except mathematical gimmicks. Because at the same time they wrote a work formula that squared things. And then they end up writing a spring constant formula that squared things. So they squared in other formulas to match this formula. And that's why that's how they rationalized it. But they had no physical evidence of it. They had no visual, physical evidence of ever collecting the extra 200, the extra joules of energy. So that's the history. It's a mockery of the scientific method. It makes science look rather ridiculous, like, oh, you just change your mind anytime you want to, and then you just discount. You were proving it. You had evidence that proved it 100%. Oh, yeah, it didn't prove it 100%. No, forget that evidence. Forget that whole argument. Forget 100 years of arguments. We were all full of shit. Here's the right answer. It's really bad science. And then to do it in the environment where you have no physical evidence of mv squared collected. Okay, nothing collected. No experiments collecting it. And Pyrrho says this doesn't matter. So the history doesn't matter. The fact that there's no physical evidence and the history basically proves you proving yourselves wrong more than once. That you're totally unreliable. All right, anyway. People in science have had all sorts of beliefs and motivation. Yeah, and clearly, if they're going to argue that they proved something, yeah, and then you're going to say, well, that proof failed, then don't you have to put a warning label on it now and say it failed? We said we proved it, but we really didn't. So you can't really trust us when we say we proved something. So unless we show you the proof, can you really trust us? In fairness. Okay, but all that gets into the system is what stands up in experiments. So here he says the words, in experiments. He's produced 0, not a single link produced. Not one single link produced. Okay, to any evidence of extra, this kinetic energy, anything besides momentum ever being collected. Momentum moves objects. Again, this is the physics girl video, but the fact is you can't use the momentum twice, in the sense that you can't turn it into smaller movements and then expect those smaller movements to go the same direction your movements go. You can't scatter light and then keep your laser beam. Say I have a laser beam and I scatter the photons. They're going the wrong, they're gone. I can't have the same strength. I can't have the same watts of laser light anymore if I'm sending light that way and I'm sending light that way. If I'm making friction, if I'm making sound, if I'm making noise, if I'm making sound and noise, same thing. If I'm changing the environment in any way, the only way I can do that is with my momentum. I have to slow down. I can't keep my momentum and make friction and make heat and make sound and make sparks and make all kinds of things. Can't do it. Can't spill the paint and pour it into the bucket. Shit. So he has no experiments. A system is what stands up in experiments. There's no experiments. 0 on his side. Nothing. Not a single link have I been provided showing me kinetic energy being collected, showing me for example, a 5-ton train going 10 miles an hour, producing twice as much light, for example, or electricity, than a 10-ton train going 5 miles an hour. Not a single example. And which is defined such that it can be tested by experiment. So he said again, you have no experimental test. You have nothing. You have not any evidence. Not even, like I said, you can't rely on the clay experiments because they're debunked by your own remodeling of the formula. Your remodeling of the formula debunks your previous experiments that validated your nonsense. So you can't use those anymore. Since you can test the formula directly. You keep saying it. Why haven't you tested it directly then? Show me the direct test. What is so complicated? You've had 300 years to make a direct test. Show me the direct test. Okay, then the whole thing is over. The whole conversation is over as soon as you show a piece of evidence. All right, it doesn't matter what those people motivation was. So it doesn't matter what their motivation was or the logic they used or the evidence they used. It doesn't matter how bad the evidence was. Doesn't matter how bad the intentions were. It's all great science because I believe it. My team did it. You know, my players don't rape women. The other teams do. Okay. You can check how it works directly. So he keeps saying it. Well, why don't you show it to me then? If you have this experience, well, you can't show me any pictures of Disneyland? I mean, nobody's ever gotten a picture off inside of Disneyland. I can't see anything inside of your wonderful park where you have all this proof. You can't get a single photo out of the park to show me your great experience. You've seen dinosaurs, real dinosaurs, and you can't take a picture of one? All right, if you love the history of science, fine, write a book. Isn't that just too stupid? Obviously, he's not saying I love the history of science. He's saying, isn't the history of a belief important? How it was constructed, how it got here, from the past to the present. It doesn't matter how it got created. Of course, it matters. It doesn't matter how a theory was introduced or proposed. Oh, amazing. However, I don't think that an accurate history at all. So he just says it. He doesn't think so. Will he provide a single shred of evidence debunking or disproving any element of the theory of the history, the statements about the history? Will he show any quotes from Leibniz or any quotes from Chatelet or any quotes from anybody or any insight from anybody demonstrating that what I have paraphrased the history to be is not accurate? No, he just says it. Okay, if you don't love history of science, fine, well, write a book. However, I don't think accurate. The problem with momentum as a general idea of energy, so that would be great if he actually had a finish to that sentence. If he could actually illustrate where there was a problem with Newton's mechanics. Because Newton's mechanics worked. Newton's mechanics will land you on the moon. Newton's mechanics will predict Halley's Comet. Newton's mechanics will tell you how big the hole will be if Halley's Comet hits the Earth. All right. Is all the things that contain energy are not in motion. So just as, again, I can show you direct quotes from Leibniz and others of the time, already understanding that there's motion inside the objects, and that you can make things inside the objects move. So the momentum is still in the object. It's just in a different form you can't see. It's not in the same direction anymore. So they already knew that. Okay. That are not in motion, like gasoline and like potential energy. So again, all the potential energy is environmental energy. It doesn't have anything to do with the systems, the closed systems we're analyzing. All right, so it doesn't play any part in these conversations about these interactions and exchanges. And whatever part it plays it in the gravitational sense, and that gives back exactly what it takes. So if there's a spring involved, the spring compresses, the spring gives back exactly what it took. So really, it was motivated by the fact that momentum is only about kinetics, which is just absolute nonsense. Okay, so momentum can be understood as being stored as energy in any form, just like energy, just like kinetic energy. You can imagine the energy being stored as the motion of electrons, or you can imagine the energy being stored as light inside a reflective ball or something. You can imagine the energy being stored in lots of ways that have to do with its chemistry or its molecular makeup or even its atomic makeup. So that isn't outside of our capacity. And what we do know, though, is that you really don't do, we can't do, what do you call it when you're trying to turn gold, lead into gold? Alchemy. We can't do alchemy. Okay, so we can all, realistically, we're not going to change the chemistry of atoms. We're just going to change the chemistry of compounds. So we're not going to change the structure of atoms. We're going to change the structure of molecules. And that has to do with heat. And heat is plays a vital role in chemistry. So that's clearly understandable. All right, anyway. And that is the only type of energy storage. So just more bullshit. Okay, yes, you always have to store it in some form that has to do with something like that. But again, I can just point out the magnets aren't doing that. Magnets aren't storing the energy because the magnets are changing at all. The magnet's chemistry isn't changing when the magnets are reacting to each other. They're excreting something constantly, the same thing. And they're just hitting each other with their water hoses when they're pushing against each other and doing similar, their vacuum cleaners in the opposite direction. But they don't themselves chemically change at all. So it's just stupid to say that's the only way you can store energy. You store energy by putting electrons and protons in positions. And when they're close to each other, there's a lot of energy. When they're far apart from each other, there's not very much energy. So he doesn't understand any of this physics. He just says this crap, again, just pontificating. The problem is finding out springs don't store momentum. All right, so let's say this is true. Springs don't store momentum. So I went to a stack exchange, physics comment that was on this subject. And the guy asked the simple question, what does a spring store, momentum or kinetic energy? And nobody could give an example of a physical experiment. They just did more of this mathematical crap. So again, it's the same bullshit. Their math says it stores kinetic energy, but they have no evidence of that. No physical evidence. Okay. Anyway, and that is easily tested. Okay, so he says it's easily tested by pushing different masses into the same spring. Then why haven't you done it? I mean, 350 years. I mean, springs have existed since the 1500s. So you've had 300 years to do this experiment and nobody's done it? I mean, it's almost too laughable to even mention, isn't it? That in all that time, your physics can't even shore up this experiment. I mean, it's bad enough you haven't redone the Eddington experiment with better technology, but not to have done these simple experiments? None of your physicists have ever been curious? Nobody ever did it? Amazing. And observing that they don't have the same momentum. So where can we observe this? Where can I go? I can go to aquariums and I can see fish, there's only 6 of them on planet Earth or something. I can see all kinds of stuff that lives under 200 million pressure of water or something. I can see all kinds of things in the world, but yet you can't show me this event taking place. Okay, but that's where he says it. Okay, so the same spring and observing they don't have the same momentum. So he's just saying that different masses go into a spring and the spring won't give back what went in terms of momentum. Momentum is not conserved. And I'll just show you the implications of that is still, we're right back to free energy again. Because there's only 2 ways I can do it, right? I can put heavy things into the spring and replace it with a light thing, or I can put a light thing into the spring and then replace it with a heavy thing. And either way, okay, depending on what formula you say is correct, either kinetic energy creates free energy or momentum creates free energy. That's what you're stuck with. So his argument is the 5-ton train, okay, so 5 mass versus 10 velocity, okay. If I take that train and go into a spring, it compresses the spring more, okay. So the spring creates, how do I do the compression vector? Well, we just make the compression vector another arrow, okay. So the compression vector of the spring is deep, is this size, okay. So that's the 5 mass, 10 velocity. And then I take the 10 now I take the 10 mass 5 velocity, and okay, so it's going to compress the spring less, so it goes in and it makes only this much, okay, 1.4. It doesn't matter what we say it is, we just know it's a smaller arrow. So logically you can understand that if I compress the spring with the 5, right, the spring is now compressed more than this spring got compressed, right? So we know this train has to leave with more momentum than it went into this spring with, right? It didn't go into this spring, so we know the spring has to somehow give it more momentum. So even though we have a certain amount of momentum going in, okay, the same momentum as this, the two momentums are equal, okay, same momentum, different amount of momentum out. So one momentum will go in and I'll get more momentum out. It's guaranteed, right? I mean, the spring is obviously compressed more than this could compress it. So it's obviously compressed more, so I have to get more out than what I put in. So I have to get more velocity. I have to get more momentum. So it's a free momentum engine. Pyrrho's theory is a free momentum engine. All I have to do is keep replacing, let light things crush into the spring, replace it with a heavy thing, and I gained extra momentum. So I can just recycle that free energy and just make billions and billions and billions and trillions of kilowatts of electricity or anything I want with my free energy machine, because if I'm making more momentum, I'm making energy. Momentum is energy. If I do 10 okay, times 5 and multiply it by 2.3, it equals joules of energy. Okay, that's what you're going to get. Joules of energy. You'll get more joules of energy out of this spring compression than this thing had momentum going in, and clearly more than this had as momentum going in. So you're clearly going to increase your energy by just compressing springs with light things and releasing them with heavy things. Free energy machine. Thanks to Pyrrho. I don't know. Is there anything else to say? This can't be true. It just can't be true that springs don't store momentum. I mean, it can't be true that both of these theories have any validity. Either one is completely wrong and one is completely right. There's no such thing as this one's partly right and that one's partly right. There's no such thing as they're both right about different things. They're incompatible notions of reality. They get different answers to a simple question. I mean, I'm trying to think of some cannonball example, but I mean, again, they still can't explain the recoil problem, right? They can't explain how they can accept Newton's third law as being real and yet claim that it's okay that the cannon recoils with 50 joules and the cannonball has 300,000. How does that consistent with Newton's third law? There's obviously more energy going one way than went the other way. I mean, it's a clear violation. All right, anyway. So I did ask as a... I probably shouldn't have said as much as I did. Okay, this isn't saying much, right? So he says, easily tested pushes different masses of the same spring and observing they don't have the same momentum. So he apparently went to some Disneyland where he saw this, but no one was able to film it in the whole history of mankind. So I said, can you provide a link to this fact being observed or recorded? Or even just a link to a physics professor saying it. Now, I shouldn't have said that part, right? Because we know there's some pretty loopy assholes out there. And like I said, I could take it to Quora or I could take it to Stack Exchange and they say these stupid things. So, yeah, I could find that link. But we really all want is to see evidence, don't we? Isn't that what we all really want? All right, well, let me just do that. So just to end, I'll show you the other Professor Lewin experiment that sort of demonstrates the point. Okay, so let me pause and find that. Oh, wait, before I get to that, the JPG guy, I was kind of disappointed that he wasted his opportunity to speak to Pyrrho and Pyrrho's precious time and all that. And he asked this question, which doesn't really this one is a biggie, it says. I don't remember saying that. Draft asked in his latest video, here is the transcribed question: why would you ever square a velocity? It's a theoretical question. So, I mean, but I'm just saying, yes, a velocity is kind of a weird thing. I mean, how could you ever make sense geometrically of squaring a velocity? It's like squaring time, or it just doesn't make any sense. When they square time, they're not squaring the time. What they're really saying is that you're doing the same thing now, and you do it the next second, and you do it the next second, and you do it the next second. So it's squared for the amount of time that you're doing the thing. Okay, but it's not really squaring the time. I don't know how to say that, right? So it's the gravity argument. It's meters per second. You're not really squaring time. You're squaring the idea of time. You're not squaring the amount of time. Like if it was 15 meters, you're not squaring the 15 meters. You're squaring the idea that you're going to do it this second and another second and another second and another second and another second, but you're not really squaring the 15 meters. You're squaring the idea of the time. Anyway, what circumstances created in the physical universe where squaring a velocity makes sense? So I'm just saying these are easy to evade questions. So I'm just saying there's no point in asking this question because this one's too easy to evade. It makes no geometric sense to square a velocity. Squaring a distance makes sense, but not a velocity. See, distances end up creating areas, and you can understand it. But how do you create a squared velocity area? What would that represent? It can't represent anything rational. A squared velocity area? No. There's no xy axis to a velocity. Because it is timed. There's no time vectors. How can you square? How can you create a time territory? It's just not possible. All right, anyway. So I'm disappointed. He wasted his chance with that one because that's not a biggie. The biggie is, how do you ever move anything? Create heat, create friction, create any movement in the universe without using something's momentum. How could anything possibly ever travel through the universe and cause events and not lose its momentum? How could you ever transfer momentum and deform an object? You can't both transfer it and deform it. That would have been the better question. Anyway, all right, so we'll go to the Lewin video. All right, this should be it. All right, so it's the air track thing again. Well, it's pretty simple. Let him explain it.
Momentum of the center of mass will not change. Only of the center of mass. Not of this car, not of that car. That's the uniqueness of the center of mass.
All right, so he's just talking about it not changing. So he didn't do a calculation to say how fast it's going, but I would obviously say it's going 1/2 the speed of the initial impulse. So, obviously again, it'd be really nice if he did have the velocities here. It'd be very nice if he actually, did the experiment with all the details, because that'd all be very interesting.
And so the center of mass will just laugh at us and ignores all these motions and will travel at a constant speed very nicely.
Right, at 1/2 the speed, because the initial impulse he gave to one car. So he's just pushing one car a velocity. Now it's that one car is going to keep exchanging the velocity back and forth. They're going to keep bouncing back and forth with the spring. So they're going to keep sending the velocity, then the car will stop, this car will move, then this car will move, then this car will move. So you can actually imagine them covering the same exact distance twice. This one has to move the distance, then this one has to move that same distance, 2 seconds later. And then this one moves the distance, and then this one has to move the distance. And while one's moving, the other one's not moving. And so you can sort of get the idea that it has to be half. So the velocity is the same for the cars constantly. You pushed it in the spring's giving back the same energy forward, same energy back, same energy forward, same energy back, same energy forward. But this sort of illustrates what I was talking about in the stop, start, that's how things move in real space. In real physics, the real elemental bits are moving, stopping. The real elemental bits of matter, electrons and protons, actually do move, stop, move, stop, move, stop. They don't, anyway. They do when they are of low energy. When they're high energy, they're not stopping anymore because they have plenty of pushers to take the place, and I don't want to get into an explanation of all that.
So if you concentrate on that little object, you may be able to see that. You may need a lot of imagination to see that, because you're going to be distracted by the weird motion of the other two objects.
It's not all that weird. It's pretty easy to follow. Even if they kept the camera on it without moving the camera, it'd be even easier to see.
This is the center of mass. It's right in the middle. The objects have the same mass. There we go.
So that's the initial impulse, is basically compressing the spring, and then he pushed it a little further than the spring's compression and started the motion of the other car. So he might have added a little bit more velocity. But the point is the ball doesn't care. It's moving at a constant velocity that's going to be exactly 1/2 of the initial velocity of the gold-colored car. The gold-colored car's velocity initiates the action. Now the action has to be spread over both the gold car and the purple car are being moved, and the thing showing you that that movement is 1/2 the velocity of the initial impulse is the little bead in the center. So you can basically see the gold car moves, stops. Red car goes. Red car stops or purple car stops. Gold car starts. That's all they're doing. One moves, then stops. The other one moves, then stops. This one moves, stops. This one moves, stops. So they're just covering the same distance at a high velocity, but the net velocity, because they're stopping, is cutting the velocity in half.
You see how complicated this motion is of the individual cars?
So it's really not very complicated, right? I mean, it's just stop, start, stop, start, stop, start.
Can you see that the center of mass is moving very uniformly, or can you not see that? Now you think you can see that. You have a lot of...
All right, so now he just uses ultraviolet light so you can see the little bead move. I mean, not useful. So anyway, that's all there is to it. So unfortunately, there's nothing qualitative in the experiment. It doesn't do much to help. It'd be great if he would have done the speed test, where measured the velocities and all that stuff, but he didn't, so we don't have that information, so I can't declare it as a proof. But I'm just saying it's another indication that clearly the momentum has to be conserved. It can't be just thrown away. If the spring is constantly collecting and pushing back, it's obviously not losing any energy anywhere, not a significant amount. So what? So this is all just garbage, horseshit, crapola. I shouldn't have to have this conversation, frankly. But anyway, I obviously have to. So yeah, tough. I guess we're stuck with it. All right. So key point: the history is important because it's terrible. There is no evidence supporting kinetic energy. No physical evidence, and every bit of physical evidence I can find indicates springs work just fine. And if they don't work just fine, you just end up creating free energy, free momentum. I can multiply the momentum using your spring malfunction theory. Okay. All right. So, till the next time and such. This has been a DraftPhysics.com video presentation. Yeah, I wish I could say thanks for your participation, but it really has been dismally unpleasant, this interacting with people. One of the trolls made some kind of comment, a rag comment about how I'd get thrown out of a bar or something, or some other kind of crap, as I'm just I was a bartender for a couple of years, and I made damn good money at it, because I have a personality, and I'm a nice guy. And that's a fact, okay? I'm again, I'm a nice person. I don't have any will to have any stupid arguments. It's you people who are rude and obnoxious and insulting and who lie. And you think people should accept your lies. You're the one who come into a comment section with your dude crap and your bro crap and your other kinds of crap. You're the ones who don't know how to have a civil conversation. You're the ones who don't know how to be stay on the subject and not get personal. Ugh, the other people should get thrown out. Quite obviously. It's just a joke. It's just funny. Anyway, till the next time and such. And so forth and whatnot.